New photos from the James Webb Space Telescope show off the bewitching beauty of the warped quasar RX J1131-1231, which is adorned with four bright spots birthed by mind-bending space-time trickery. The James Webb Space Telescope has captured a breathtaking image of a distant quasar, a super bright object powered by a black hole. This image isn't your typical space picture though. A cosmic phenomenon called gravitational lensing has transformed the quasar's light into a stunning Einstein ring. Gravitational lensing also magnifies our view of extremely distant objects like RX J1131-1231, which would otherwise be almost invisible to us. This magnification effect can create bright spots in lensed objects, which shine like brilliant gemstones in a piece of jewelry, especially when the distant object is not perfectly aligned with the observer. The quasar, known as RX J1131-1231, resides an incredible 6 billion light-years from Earth. In the foreground of the image lies a massive elliptical galaxy. Its powerful gravity bends the light from the distant quasar, creating a bright arc and even duplicate images. This creates a mesmerizing effect resembling a ring adorned with jewels. These quasars are fueled by immense amounts of gas and thus swirling into a galaxy's supermassive black hole. This feeding frenzy makes the quasar incredibly luminous. According to the European Space Agency (ESA), the gravitational lensing effect allows astronomers to peer into the region around the black hole in these distant objects, offering valuable insights otherwise impossible to obtain. Measurements of the X-ray emission from quasars can provide an indication of how fast the central black hole is spinning, and this gives researchers important clues about how black holes grow over time. In the new JWST image, the elliptical galaxy that serves as a gravitational lens appears as a small blue dot at the center of the ring. This galaxy acts like a natural telescope, amplifying the light from a distant quasar that would otherwise be too distant to study directly. If a black hole grows primarily from collisions and mergers between galaxies, it should accumulate material in a stable disk, and the steady supply of new material from the disk should lead to a rapidly spinning black hole. On the other hand, if the black hole grew through many small accretion episodes, it would accumulate material from random directions. Observations have indicated that the black hole in this particular quasar is spinning at over half the speed of light, which suggests that this black hole has grown via mergers, rather than pulling material in from different directions. The recent image was captured using JWST's mid-infrared instrument MIRI as part of a comprehensive study on dark matter and its distribution across the universe. Combined with previous observations from other telescopes, RX J1131-1231 is now regarded as one of the most exceptional lensed quasars ever discovered. Gravitational lensing occurs because all matter in the universe warps the space around itself, with larger masses producing a more pronounced effect. Light passing near massive objects like galaxies bends due to the warp space around them, visibly deviating from its original path. This gravitational lensing effect magnifies distant astronomical objects, enabling astronomers to study those that would otherwise be too faint or distant to observe. X-ray emissions from quasars offer crucial insights into the spin rates of central black holes, offering clues about their growth. If a black hole primarily grows through galaxy collisions and mergers, it accumulates material in a stable disk, resulting in a rapid spin. Alternatively, if it grows through numerous small accretion episodes, it gathers material from random directions. Observations of the black hole in quasar RX J1131-1231 show it spinning at over half the speed of light, indicating growth through mergers rather than random accretion. Thank you for watching. If you've enjoyed our videos, subscribe to our channel for there's more to come.